It's big because it is about solving the biggest pain point in the over 40-year history of our industry. This partnership has a vision that is the end of mobile dead zones.
The media is going to portray it as, oh, other operators are going to be killed by this.
We've all read about somebody who's, say, been hiking and got lost and perhaps died of thirst or exposure. But now you can call for help.
Yeah, world domination. T-Mobile is going to take over everywhere. Suddenly, you're going to be able to do video calls and download hundreds of megabytes anywhere on the planet. And there has been a bit of that. I think it's not been too bad, but I still think there is an element of not understanding what it actually means and what it's actually for.
One thing I will for sure miss about Utah is this awesome view from my apartment, but I just wanted to hop on here really quickly with you guys and talk about, the obvious, the deal between T-Mobile and Starlink. So the gist of this is that T-Mobile and SpaceX are partnering, and they are hoping that your 5G phone will connect to satellites as early as next year. This coverage above and beyond promises an end to dead zones, but this is, of course, if you can wait until we get Starship up and running so that they can launch those V2 satellites. Mobile phones would be able to connect to satellites and use a slice of connection providing around 2 to 4 megabits per second connection across a given coverage area. We also learned on Twitter that Elon has confirmed Tesla will use the technology for the premium connectivity feature in their electric vehicles. Currently, Tesla uses AT&T's network for things like live traffic visualization, satellite view maps, and music streaming. And it might not just be limited to T-Mobile. Apparently, they are seeking partnerships with mobile carriers worldwide who would be interested in reciprocal spectrum sharing agreements so that their customers could link up with SpaceX. So many of you guys asked me to make a video about this, so sorry that I haven't had much time to dive into this or get it out there in a timely manner. I am in the process of moving, but instead of just telling you what we all heard in the presentation, I wanted to reach out to someone who knows everything about Starlink, even more about Starlink than I do. Why? Because he's created his own Starlink satellite tracker, and that is my friend Mike Puchol. He's in Barcelona, Spain, and so here's some of our conversation.
First of all, maybe just give people a little background on your project, how I discovered you in the first place. You are serious about tracking the Starlink satellite, so how has that evolved?
So since we last spoke, there has been many changes in both in Starlink and in the tracker that I built. So they have been launching significant amounts of satellites with inter-satellite links now with the optical satellite links, the space lasers. So those have been something that I have been adding quite a lot of code to the site to simulate, and it's now actually working. So any satellites that are within the orbital positions that they're supposed to be in, if they are where they're supposed to be, then an optical link can be established, and I show that in the map. So any planes that are linked by ISL are actually shown now, and any satellites that have connectivity to a gateway through that optical link will also be able to provide service. So you can now simulate things like what's my service going to be in the middle of the Atlantic if I only had inter-satellite links over me. So whether that matches reality or not, only SpaceX knows. They could have all the inter-satellite links on. They could be linking satellites that are not necessarily directly in front of each other. So they could be skipping one slot and linking to the next satellite down. They could be doing many things that are different from what the simulation says, but it's, as usual, it's the best guess. And yeah, for working out how the whole thing is put together and how it's operated, then it's actually quite useful. So the simulator will be able to show you what cells are actually active, which ones are getting service from what satellites, and that will give you an idea of what the actual capacity and the throughput per cell is in a particular country. So you could pick Spain, for example, and say, so Spain is made up of 3,000 cells, and if there are so many satellites over it with 24 beams per satellite, you could then work out how many megabits per second every cell is getting effectively, and that would be able to to tell you what the expectation of service is like. Again, that's going to be the best case because you're going to distribute all the capacity over all the territory, which is not realistic because there are, large cities, for example, are likely not to have that many Starlink dishes in them. Places where there's fiber are going to be less likely to have terminals in them. So you would assign resources based on where you have demand rather than just covering everywhere. Interestingly, however, when mobile terminals are enabled and start coming into play, that's going to change because you are going to be able to, you're going to have to provide capacity to any cell because suddenly all your terminals are moving all over the place, and you're going to have to be able to assign service to anywhere based on where the terminals are moving around. So that's going to be a much more complex problem to solve.
Yeah. So I guess what was your reaction to the big announcement between Starlink and T-Mobile?
Yeah, so I think the first reaction is this is going to get massively overblown in terms of the media is going to portray it as, oh, other operators are going to be killed by this, world domination. T-Mobile is going to take over everywhere. Suddenly, you're going to be able to do video calls and download hundreds of megabytes anywhere on the planet. And there has been a bit of that. I think it's not been too bad, but I still think there is an element of not understanding what it actually means and what it's actually for. The service that has been announced is meant as a last resort capability for people that are literally in the middle of nowhere, out of cellular coverage. There's no 911, so there's literally no service from anyone, because if you're in an emergency situation, the way cellular networks work is if you dial 911 or 112 in Europe, any network that's within reach will accept that call. So even if I'm not a customer of T-Mobile, even if I don't have a SIM card in my phone, I can dial the emergency number, and any network that can receive my, is within coverage, will accept that call and put it through to emergency services. So this is disaster scenarios where all cellular networks have been wiped out, or I'm in the middle of nowhere with no cellular service whatsoever. There are services that already cater for this and have been around for years, such as Iridium. I have a tiny little gadget, which is a Garmin InReach, which you pay about $20 a month for. And it has an emergency button on the side, and anywhere in the world, well, pretty much anywhere, you get this thing out, you press the button, and your location is sent to emergency services. You get rescue teams sent to you, if you have a medical emergency and so on. So this sort of capability is already out there, and people that desperately need it. I mean, when you travel to Africa, you go to places that are really remote, and where if something happens, you do need to send out an SOS and get someone to fish you out. So if you do need that sort of capability, there are services already out there for it. What this enables is anybody that's a normal T-Mobile customer to roam around anywhere and be able to send out an emergency message pretty much from anywhere. This is something that may be useful in many occasions. I mean, if your life depends on it, then you'd pay anything for that at that moment when you actually need it. But what the business model is for that as a sole capability, such as T-Mobile want to provide, which is just service for cellular phones, that is something that I have my doubts about. As an additional capability for Starlink's constellation makes total sense, because it's an additional antenna that you put on the satellites. You're going to be launching them anyway, so add an extra antenna. This antenna is capable of projecting spot beams, which are fairly large. So this limit that Elon was talking about, thousands of calls per cell, I'll get to this in a minute. But the cells are fairly large. So the amount of people that if you have a lot of demand in a particular cell, then 2 to 4 megabits per second is going to be constrained. So I see this as a messaging only service. I would actually, personally, I would restrict it to messaging only. I would not allow calls, because voice takes considerably more resources. A voice call is continuously using data. Right. A message is I have this block of text, it's sent, that's it, done. I can send millions of messages in the same bandwidth that these 1,000 calls are taking. So I would keep it as a messaging only service, but we will see how it progresses. If they don't have a lot of demand for messaging and the satellites are just sitting there doing nothing, then okay, fine, you enable calls. Why not? But the data throughput, as was mentioned in the announcement, is quite limited. From a bit of digging that I've been doing, if they were to use the lowest LTE bandwidth, which is 1.4 megahertz in single input, single output, so SISO, no MIMO, there's no multipath from a satellite to your phone. There's literally a single path, so you cannot take advantage of MIMO. The maximum achievable throughput is about 3 megabits per second, which is right in the middle of the 2 to 4 that was announced. So I'm guessing that that's what they're going to do, because a narrow signal is also easier to pick up. You don't need to demodulate a wide amount of spectrum, which potentially carries a lot more interference than a very narrow signal. So a narrow signal is easier to hear amongst all the noise than a narrower signal. So there are reasons for that to be and not offer bandwidth as if it was a land mobile network. So those are the sort of constraints and the restrictions. It's definitely not going to kill ground-based cellular networks. It's not going to kill fixed wireless access. It's not going to be 5G from the sky in the way that operators have built it. So it's an additional capability. It's very interesting. It has its purpose, but it's not going to be a mass market, generate billions of dollars in additional revenue. The additional revenue is going to be, if I have two carriers to choose from and I go out on the mountains often, I do. Which one would I pick? I'd pick T-Mobile because it's on my phone now. Why not?
Right.
So it's going to be in the way that Apple builds some of the services it offers, some of the iCloud services it offers as value-added services that make people choose the iPhone over Android because of these services that are attached to it and you get for free. So it's a bit in the same line. I would say it's an additional capability that Starlink can provide without too much trouble, and that T-Mobile can use to essentially get more customers. So makes sense.
And I don't know if you followed Dave Lee, but he tweeted to Elon, and Elon answered saying, "Will Tesla cars have an option similar to this in the event of an emergency?" And Elon said yes. So, I mean,
it's very easy. Yes, it's very easy. So the important thing about this announcement is that it's going to use existing phones, technically unmodified. So your normal smartphone will be able to talk to the antennas on the satellites. What this means is that the modem that's in every Tesla vehicle that also is used for downloading software updates and enabling features and getting telemetry and all of this stuff can also be used for this, because it's exactly the same. It's exactly the same type of technology. It's a cellular modem. It's very easy to add the capability. They may want to add an antenna that's more efficient in talking to a satellite, so that it's easier for the vehicle to acquire the satellite signal rather than a smaller antenna meant for terrestrial networks. But that's about it. So yes, definitely makes sense.
Well, and time will also tell, because before this can even happen, we need Starship launching these V2s, right? So
yes, now there's been an interesting development where, and this may indicate certain things, and you could make hypotheses out of it. SpaceX has indicated that they're going to launch a mini V2. So and this is a bit that I want to clarify. There's usually confusion between Gen 1 and Gen 2 and the satellite versions. Starlink started with version 0. something, 0.7, 0.8. Eventually there was version 1. They're now launching version 1.5.
Right.
Version 2 is an extra, a different hardware version from what they've been launching so far. Gen 2 is the second constellation that they filed for, with 30,000 satellites, different shells, much lower orbital altitudes, different capabilities in the satellites, V-band, for example. So a completely different constellation. They have two. They have Gen 1, which is 4,428 satellites, and they don't have a limit unless they substantially modify the radio characteristics of the satellites. If they suddenly said, oh, we're going to add V-band and we're going to add something completely different to these satellites, then they would need to refile, at least with the ITU, for compliance with RF limits and so on, likely also with the FCC. If all they are doing is saying V2 is a better version of V1.5 with more battery capacity, more solar capacity, more spot beams, but same effective power projected on the ground, it's just that one satellite can project more of it, that wouldn't really be a difference in technical terms, because essentially having one satellite cover more ground, but the actual effect on the ground and then on others that may object to this is the same. So there's no added interference potential for other operators. So Gen 1, Gen 2, and then versions. Versions can be, there's no reason why they cannot have a V2 or a V1.9 or whatever they want to call it in the first constellation in Gen 1. So what they've said is they're going to have this V2 mini, which is going to be a cut down version of the V2 that they were meaning for Gen 2. I'm guessing it's going to have less solar panels, less battery capacity. So those are the things that you can possibly cut down easier on in order to make it fit into the Falcon 9, so that they can start launching this new version of satellites with the Falcon 9. Now, the hypothesis you could draw from this is that they are going to be late on Starship, or they have seen delays, and they know that they're going to be delayed for whatever reasons. It could be regulatory, there could be technical reasons, there could be all sorts of reasons why there could be extra delays. But if they have spotted this, it's smart to say, let's get a cut down version of what we were going to launch with the PEZ dispenser in Starship, so that we can start launching that in Falcon 9.
Yeah.
Because otherwise, if they need to continue manufacturing version 1.5, that's a commitment in terms of parts, supply chain, logistics. And if you have V2 ready to go, why not adapt it so that you can start launching a reduced version of it with Falcon 9? So that's where it stands now.
I would expect the pricing for this service to be the uncarrier's favorite price, the price that we've made famous, which is that we expect on our most popular plans for this service to be included for free.
You don't really want to scare customers by saying, and this will be an extra $15.99 a month,
Right.
because a lot of people would go, well, for that I can buy my InReach Mini. The cheapest plan you can buy is, I mean, the device is about $300, and the lowest monthly fee you can pay is about $12. And you even have an option to only pay when you need it. So if I'm going to go on an expedition to whatever, Mount Kenya, I can then pay for a month, and then I have the emergency service during the time that I'm going to be needing it. So I can turn it on and off, unless there's an attractive side over existing emergency services and emergency messaging, or even voice service that there already exist. It doesn't really make much sense. So my guess is that initially they're going to go with, it's part of the same pricing. That means that T-Mobile is going to eat some of the cost of launching this, because it's not going to be for free. I mean, SpaceX is not going to say, yeah, you can. We're going to put a big antenna on our satellites, which is going to require more power, for more batteries, more solar panel capacity, or reduce lifetime of the service life on the satellite. So we're going to need all these things. All of that costs money. So but T-Mobile is going to have to pay for this.
Yeah.
Now they could say, well, it's a marketing expense, and we just add it on the price, and people will just pay the same price that they pay, and we eat it as a marketing expense. But who knows? But by the time they launch it, I'm guessing that they will have made a decision as to what the pricing should be. So
Yeah, I wonder how many new people are going to sign up. Like, I mean, I'm often in the mountains and without service, so you know, it would definitely
Mm.
be interesting to me. I don't know if I'm going to switch, but it has me thinking about
Mm.
it, you know?
I think there are going to be, so if you are in an area where where you have options, then maybe. If you're in an area where your normal cellular service is with someone else and T-Mobile's coverage is bad, then you're not going to switch,
Right.
because that capability alone is not going to make you say, "Oh, I'm going to accept mediocre service 99% of the time, because the 1% that I'm out in the mountains, it is really good and really cool and can save my life." So I don't think that's going to happen. There may be people that may get an extra phone with an extra line. I don't know. I
Right.
mean, people are free to do with their money what they want, but
Will T-Mobile service improve just naturally? Like, will it always be connected to Starlink, or will it be like an as needed? Like, I'm a little curious about that.
yeah. So the issue of projecting beams from a satellite onto the ground is that you're creating noise everywhere that you are projecting that spot beam. So unless T-Mobile says we're going to reserve 5 megahertz of spectrum just for this and not use it on terrestrial networks at all, you are going to experience interference from the satellite. There's no way not to do it, because your phone has to receive your ground network if it's available, plus the satellites. If you're in an area where you're within reach of a ground network, but you're on the edge of a cell and your signal is not that good, and you have this satellite beaming a signal onto you on the same frequencies, then you're going to have interference, and your actually quality of service is going to degrade. So they have two options. They can either reserve spectrum just for this and say, yeah, it works everywhere. It's blanket everywhere. Satellites basically cover everywhere, because that particular 5 megahertz is reserved just for this and not for terrestrial networks. Or they could say, okay, project beams only in these areas where we don't have ground network.
Right.
So that would be a filler coverage. So a T-Mobile customer would get whatever ground service they're experiencing right now, with the added benefit that if they step away from that and they are within reach of a satellite, then they will get service from the satellite at the reduced service, so messaging and so on.
What do you think they'll choose?
I would go for the latter. So
Killer.
the thing is I'm not familiar with T-Mobile's PCS spectrum and this particular band that they were talking about. I'm not sure how much of it they use, or whether they are actually using that chunk of spectrum for PCS nationwide. How many customers are using it? What would be the impact of dedicating that 5 megahertz to this? If they say, well, we have a few thousand customers on it on a few places in the country, we might as well just reserve it for Starlink and stop using it for terrestrial service. From a regulatory perspective, it would also make sense to reserve it for space, because the other issue that all these operators that meant to provide cellular service from space have is that regulators license cellular bands for terrestrial use, and they license space segments for space use. So you cannot use KU band that Starlink uses for the normal dishy service. You cannot use that for ground communications. And that is why they're having a massive fight with Dish now over a chunk of the 12 gigahertz band that Dish wants to repurpose for cellular, for 5G cellular networks on the ground. And Starlink obviously says, yeah, this is going to cause massive interference to my customers, which is true. In the same way, you cannot just take terrestrial cellular spectrum and say, oh, I'm just going to use it from space. You need to license that. So the regulators actually need to agree to that. And I guess it's a lot easier to say, we have this 5 megahertz that we own, we pay for, we're going to reserve it just for space use. It's not going to be used for terrestrial customers anywhere within the US, which means that the regulator has it easier to get their heads around making that change. If you go with an approach which says, well, yeah, we're going to have it mixed, there's going to be areas of overlap, and in some areas we may have ground antennas, and then there's going to be some space coverage overlap, and yeah, that creates uncertainty. That creates, on the regular side, the regulator is always going to tread carefully, and it's going to always stay on the safe side, which is, if there's a chance that this could cause problems to terrestrial networks, we're not going to allow it, because the potential for interference, I mean, imagine if you're trying to do an emergency call over a terrestrial network and your satellite is actually interfering with that. That would be a really bad situation. So, that's something that they cannot allow to happen. So if there is even the least chance of that sort of thing happening, then the regulator is going to be very careful about it. So they still need to work through the licensing side of it.
Yeah, I really wonder how that's going to play out.
It's uncertain. I don't think they have. So again, I'm not sure how. I need to dig into and learn a bit about how T-Mobile uses that piece of spectrum, whether they have a nationwide assignment or whether there's regional operators that may have it. So if they have a nationwide license for it, it shouldn't be much of a problem. If they choose to say, we're going to reserve this piece of spectrum just for this, can you please repurpose it for space use? The FCC will likely say, yeah, why not? It serves the public interest, and increases coverage in areas where there's none, and so on. So it's for the public good. If the public good can be impacted by this, meaning there's a small operator in Utah that uses this spectrum as well, and has the chance of being interfered with, then they're certainly going to object, and that's where it could get messy. I think that the whole, we're just going to provide 5G service from space has been a bit of a blown in general. So my message is to be careful about claims of performance that are on par with terrestrial networks. There are technical challenges. I mean, there are certain components of the LTE standard which actually work against this. I'll give you a very quick example, and it's very easy to understand. LTE networks are synchronized, which means that the base station issues a set of time slots and frequency subcarriers within the LTE signal. So your phone will be the tower will tell your phone, you can talk in this subfrequency of the carrier and in this particular time slot. So we'll basically give you one piece of the resources of that cell for your phone to transmit stuff to the network. And if you need to transmit more, it will say, oh, I'll give you a few more chunks of this. So it can dynamically allocate all this chunk. This requires very careful timing from everybody involved. So the base station is GPS synchronized, has a very accurate time base. The phones need to adjust their timing according to how far they are from the base station. So a phone that is 30 miles away from a base station, the time for the signal from the phone to travel to the base station means that if it just sends without the synchronization happening, it will arrive not at the right time slot. By the time it gets to the time station, the time delay will put that transmission in a different slot. So it could actually overlap with someone else's transmission. So cellular networks use a concept called time advance, which is the cellular network will range how far the phone is and will tell a phone that's very far away, transmit slightly ahead of when you should be transmitting, a few microseconds or milliseconds earlier, so that your signal, because it's going to take longer to arrive, will actually arrive synchronized with the actual time slot where it should be. There is a limit. So as with everything, the designers, you remember the Millennium Bug when computers couldn't deal with too many bits for the year. So in 1999, everybody was panicking because the designers of the clocks and computers never thought they'd get to year 2000. So it's a bit the same. The timing advance is a binary value. It has a certain length, and you cannot have something that's more than, I can't remember the actual value now, but let's say it's 50 miles. So your phone cannot, the timing advance only goes out to 50 miles, not 500 kilometers up into space. So how you synchronize the signals from a phone that's so far away from the satellite without modifying something in the LTE stack that's actually on the phone, that's quite hard because you literally run out of distance to tell the phone, transmit so far in advance because you need to cover the distance all the way to the satellite, and that time delay is actually in the milliseconds. It's not in the microseconds as you have with ground network. So, that one is, for example, one technical challenge that's going to be significant to overcome. So yeah, it's not easy.
No. Yeah, I mean, I'm glad I reached out to you because you understand this stuff way better than I do.
It's okay.
Yeah, no, but I mean, overall, it is pretty exciting, but yeah, maybe a little bit overhyped.
Yes, it's definitely cool. It's definitely useful. It's definitely useful for people that have a normal phone and say, well, actually with my phone and my service, I can go out and be in touch and, be able to reach out in case of an emergency or send a WhatsApp message in the middle of nowhere just because I can. That's really cool. That's neat. And if the experience is the same as you have on a normal mobile network, then that's great as well, because, for example, this Iridium inReach thing that I have, when you want to send a message, it needs to wait for a satellite to actually come over, have a time slot available, synchronize with the satellite, and then so a message can actually take 3, 4, 5 minutes to send sometimes. Sometimes it takes a few seconds, sometimes it can take minutes. So if you have the immediacy of a cellular network, that is really, really cool, and it's a differentiator with some of these other systems. So yeah, I mean, I think it's a great announcement because it will enable other things that we are not aware of, such as vehicle emergency, crash detection, and automatic emergency communication in case of a crash. So there's all sorts of applications that you could imagine for this.
But it still won't work if I'm, hundreds of feet below ground in a cave. Yes,
correct. For caves, we're not there yet. We're not there yet. Yeah. For caves, you're still better off leaving someone outside with a note.
Yeah.
And I should be back by 10.
Yeah. Yes.
So yes, I know that this was big news, and I just wanted to take it a step further by actually talking to someone who I think had some great insight on this. So hopefully you guys enjoyed this conversation. Again, I'm in the process of moving, but I'll be in Portland soon, and I have some really exciting things on the way, some stuff that I'm planning to really take the channel to a new level. So get excited for that. Thank you so much for watching this video. Please make sure to like and subscribe, and I'll see you in the next one.